Okay, my beauties, we are looking at 4.4 still, but day 2, so more trig functions of any angle. So we're going to look at a couple things that might help you with some of these, and these are called reference angles. So this is the acute angle that's made specifically with the x-axis. Okay, so it's the acute angle that's made with the x-axis, and we call this theta prime. So if I had an angle that the terminal side was in quadrant 1, it would be this little angle right here between the positive x-axis and the terminal side. So if my angle ended in quadrant 2, the reference angle would be right here between the terminal side and the negative x-axis. So this would be the reference angle, and this one right here would be the reference angle. Okay. So this is really helpful when you're looking at the unit circle, because you want to know if this is like a pi over 4, then you know where you're at in the unit circle. All right, so we were going to sketch the angle and find the reference angle, theta. So 225 degrees. And to find the reference angles, you're always basically adding or subtracting either 180 or 360 to figure out what that acute angle is. And we always want it to be a positive acute angle. So no negative angles, we're just talking about the positive acute angle made with the x-axis. So we just want this little part right here. So this extra curve we don't want. So I'm going to take the 225 and subtract away that extra 180. And that means the little amount left is 45 degrees. So negative 330 would go almost all the way around. So this little angle here, well, the whole circle is 360. So negative 330 plus 360, that little amount left right there would be a 30-degree reference angle. All right, so negative 2 pi over 3 is this angle right here. And we want this remaining part, so these two angles together make up 180 or pi. So negative 2 pi over 3, the given angle, plus pi would leave us with pi over 3. Or if you kind of think about it, if this is 2/3, then this part would have to be 1/3. So 2/3 pi and 1/3 pi. All right, and 3 pi over 4 would be right here. So we want to figure out what's left. Well, these two angles together would make up 180 or pi. So pi minus 3 pi over 4 would be pi over 4. Or again, if you think about it, 3/4 plus 1/4. So if this is 3/4, then that little area has to be 1/4. So those are called reference angles. All right, and example 2, more practice with those trig identities, but finding actual values instead of just proving trig functions. All right, so here we are given the cosine of theta is a negative 3/7, and sine is negative. So that's important to realize we are in quadrant 3. So cosine is negative, sine is negative. But if cosine is negative, that means secant is negative. So I chose to use the reciprocal identity to get secant is a negative 7/3. Reciprocals to me are the easiest ones, so I always look for a reciprocal identity if I can. All right, so after that, I can't use a reciprocal. So I decided I'm going to use Pythagorean identity. Sine squared plus cosine squared equals 1. So if I subtract 9 over 49, I get sine squared equals 40 over 49. Take the square root of both sides, and sine equals negative root 40 over 7, which is negative 2 root 10 over 7. The reciprocal of sine is cosecant, so I took the reciprocal and got negative 7 over 2 root 10. Multiply top and bottom by root 10, and I got negative 7 root 10 over 20. Now I'm kind of stuck again, so now I could use another Pythagorean identity. I could use a quotient identity. So I just chose to use another Pythagorean identity. Tangent squared plus 1 equals secant squared. So we had secant, so negative 7/3 squared. So this is 49 over 9, so I subtracted 9 over 9 and got tangent squared equals 40 over 9. So tangent theta equals 2 root 10 over 3. And I know tangent's positive because cosine and sine are both negative. And thinking about the quotient, a negative divided by a negative is a positive. And the reciprocal is cotangent. That's supposed to be a t there. And so I get 3 over 2 root 10, multiply top and bottom by root 10, and 3 root 10 over 20. So we found all of the trig values using trig identities. All right, so B's little here. We have cotangent is -5. We have cosine is negative. So cotangent's negative and cosine's negative. So that means we're going to be in quadrant 2, because that means cosine is negative, but sine is positive. Because we have to have one negative and one positive for cotangent to be negative. And then again, I always look for the reciprocal if I can. So the reciprocal of cotangent is tangent. So tangent is a -1 over 5. -5 is easy to work with, so I decided to use my Pythagorean identity here. So 1 plus cotangent squared equals cosecant squared. So cosecant squared equals 26. Take the square root of both sides. Cosine equals root 26. Sine and cosecant are reciprocals. So sine is 1 over root 26, which is root 26 over 6. And then I could do another Pythagorean identity, but since I already did a bunch, I decided to show you the quotient identity. So quotient, I used the fact that cosine over sine equals cotangent. So now I multiplied both sides by 1 over root 26. So I got cosine equals -5 over root 26, which is -5 root 26 over 26. And cosine and secant are reciprocals, so take the reciprocal, and secant equals -root 26 over 5. And we are done with 4.4 trig functions of any angle. Thank you, thank you, thank you.